everyone. So first off, thank you, Erica, for organizing, and thank you to the team, and thanks everyone for coming so early. My name is Charles. I'm one of the co-founders of Espresso Systems, and today I'll be talking about some of the problems and the implications with the rollup-centric roadmap, and all of the thousands of rollups that are coming out today, and what we are building at Espresso to try to solve some of those problems. Who here has sent a transaction on a rollup, like Arbitrum1? Or how about like a Korean rollup, like maybe Chroma, like Optimism Korea, yeah? Has anyone built their own rollup? Nobody? Okay. Well, it's actually, okay, well I know Zach has. So it's actually very easy to build a rollup these days because there are so many companies like Caldera and Conduit and AltLayer that just let you spin up a rollup in one click. So there are truly thousands of rollups. We at Espresso are working with probably almost 100 rollups. I mean, they aren't all using Espresso yet, but we talk to many of them, and there are more and more every day. And there are actually two problems with this, right? So on the left side, there is a security problem. Rollups basically have a central server that is operating the sequencer that decides the ordering of the transactions and also which transactions to include. And that's actually a security risk. I'll talk about that more. And also there is a interoperability problem, right? So if you have thousands of different rollups and you have assets on different chains and you have transactions on different chains, it's actually very difficult to communicate between the rollups that you want to use and to move assets between them. So there's a lot of usability problems and there's also a lot of security problems. So what we're building at Espresso, we call it a confirmation layer. Now, why does that solve both of these problems? So I'll talk about the security problem first. Right, so as I mentioned, every rollup basically has a single central server that is deciding which transactions to include and what is the ordering of those transactions. Now, that is just one server, and even if you trust like Arbitrum1, because Arbitrum1 is it's run by the foundation, it's run by the DAO, it's got a very talented team. Even if you trust the sequencer to be honest, it can still get hacked. And when there's thousands of rollups these days, you may not necessarily trust a very small rollup that's maybe run out of someone's garage. So even if they're, they don't get hacked, you might not want to trust them. And the truth is, if you were to hack any sequencer, like a big sequencer, you could cause potentially even billions of losses, even if it's a temporary hack. How do you do that? Well, all you need to do is a hacker just confirms a transaction on Arbitrum, right, that deposits many millions of dollars into a bridge or into Binance or Upbit. And then after that deposit is credited, they'll just revert that transaction, like the transaction never happened, and that's suddenly many millions of dollars of losses. So that's the security problem. There have been many hundreds of millions, billions of losses from hacks of centralized servers. Now, there hasn't been a huge sequencer hack yet, but it's just like any other centralized server. The hacks will come if there's money to be made. So that's the security problem. Now, let me just preview a little bit. Why does a confirmation layer, what is a confirmation layer, and why does that help solve the security problem? So if you have a confirmation layer, if you have some system that can tell you within a few seconds that your transaction is final and will definitely not be reverted, that's what we're trying to build, and that's how it solves the security problem. Let me talk a little bit about why a confirmation layer also helps with interop, which is seems like a separate problem, but it's actually very related. So let's say you have a bridge, right? Has anyone used a cross before? Or maybe like layer 0 to move assets from one chain to another? Well, basically what's happening here is they have different designs. Some are liquidity based, some are like a multi-sig, but basically if you want to move assets from say Arbitrum1 to Optimism, basically what you're doing is you're locking your assets on the first chain, the source chain, and then there's basically a message being sent from the source chain to the destination chain that tells you, okay, these assets are locked, you can mint them on the second chain. So the reliability of that message is very important, right? The destination chain needs to know that the source chain, the transaction that locked your assets is completely final, it can't be reverted, and you also want it to be very fast. Even if each sequencer, like each rollup sequencer has just a very small chance of being hacked, like P% chance, if your bridge app is on, say, N chains, then that chance of a bridge experiencing problems will just blow up. So security is extremely important, and it's very related to interop between chains. And as I mentioned, for Web3 applications on different chains to compose, not only do you need to communicate between them, you also need to have very, very low latency, right? You don't want to be waiting 10 minutes or even hours to move assets from one chain to another chain. And ideally, in the longer term, you want what is called synchronous composability, where maybe on Arbitrum, you can even call a function on another chain, right? Like you can do it all in one go, right? You can put money in and do a swap on Optimism, and then have that asset back on Arbitrum. That's the ideal in the long term. This is not just about between multiple chains, right? This is also about Web 2, right? So imagine if you're depositing money into Coinbase or Upbit. That exchange, before they credit you, they need to be sure that your transaction is final. Right now, for some chains, many rollups, it takes 30 minutes or even more, like hours, to deposit your assets before. Maybe some exchanges will let you trade with those assets, but they definitely won't let you withdraw that amount of value. So it's very important for interop between any type of system, whether it's a Web 2 or Web 3 with chains, to have very, very fast confirmations that the transaction is really, really final. Now, one question is, what is a reasonable trust assumption, right? So as I mentioned, if it's a small chain, we're working with various smaller Arbitrum orbit chains, like say Rari chain or Ape chain, that are already supported by some centralized sequencers. Unfortunately, these exchanges are making users wait half an hour or even more for a deposit on those chains to hit, because they simply do not trust that a single server. But what is a reasonable trust assumption, right? Like, would you trust, say, this set of Ethereum validators, for instance? If the Ethereum validators could sign off, or some validator set similar to Ethereum can sign off within a few seconds that this transaction is final, it definitely will not be reverted, maybe an exchange could accept a deposit in just 5 seconds. That's already what we're working with many major exchanges on doing, in actually 5 seconds with the chains that use Espresso. So yeah, like I said, this exchanges and all apps really need to be certain that a transaction is final. If they allow a transaction to be considered final, but then the transaction actually is reverted, again, that's billions and billions of dollars of losses, right? In the exchange case, if you deposit into Coinbase, then the rollup reverts the state, but the user has already deposited and sold it all into USDC and then withdrawn it. That's a disaster for the exchange. That can be billions and billions of dollars. The same applies for any bridging app on Ethereum or the rollups. It's actually a little bit better with rollups because there's the native bridge, right? Many rollups that settle on Ethereum have a native bridge. For instance, if you wanted to withdraw from a rollup, you definitely can. However, the problem is it takes hours or even days. And there's many reasons why the native bridge doesn't really work well for cross rollup communication, right? Many rollups are only checkpointing to the settlement layer, to Ethereum, very infrequently, like many hours at a time. There's long settlement times, and Ethereum itself also, Ethereum has a block time of 12 seconds, but many people don't realize the finalization time, the finality time of Ethereum's consensus is actually 15 minutes. So you actually need to wait for the transaction to have been included in a block for about 15 minutes before you can be certain that Ethereum's consensus does not revert it in the case of some edge case or some attack. So let me talk a little bit about what we are doing with Espresso to try to solve this problem. So Espresso currently has built a confirmation layer. So if you see the system in the middle, That's a confirmation layer that sits between the different rollups, the different L2s, and the L1 Ethereum. Each rollup basically not only, so let's say a user, let's go through the transaction flow, right? If you're submitting a transaction to a rollup that uses Espresso, for instance, basically that will be sent to Espresso's confirmation layer for a quick confirmation. And I'll tell you a little bit more about how it works first, but basically Espresso in good conditions can guarantee a confirmation that the transaction is final within just a few seconds, around 5 seconds. Then later, whenever the rollup settles the batch of transactions on the L1, each rollup has a contract on Ethereum, right? Basically, that contract is upgraded so that it will only accept a batch that proves that it was previously confirmed by Espresso in the same order. So the rollup can only settle on Ethereum once every few hours, but users and apps can know that the transaction is final just within 5 seconds. So that's the big utility, and that's how it boosts both the security and the interop. Now, how do we achieve that? So there's actually, if you're familiar with the CAP theorem, it's like a concept from computer science in consensus. Basically, it states that consensus protocols always have to have some sort of trade-off. Ethereum's consensus, right, Gasper, has a property called dynamic availability. What does that mean? Ethereum's consensus basically means that it can survive like a World War III event. So if like 90% of the nodes go down, Ethereum's consensus doesn't freeze, it'll just keep going. So that's the property dynamic availability. However, the trade-off is that finalization takes quite some time, right? It takes 15 minutes on average. On the other side, what we have built with Espresso is called Hotshot. It's a consensus protocol that has this other property called optimistic responsiveness. What this means in good conditions is that basically you can get complete finality within 5 seconds. And it's as close as possible to the performance of a centralized sequencer that many rollups use today, but it's still got that security of a large set of nodes. We've actually built Hotshot so that it can scale without much performance degradation to hundreds of nodes. So the ultimate goal is to basically scale to the size of the Ethereum validator set. And with tools like restaking, we can actually have the economic security and the validator set of Espresso essentially mirror or be the same as the Ethereum validator set, but with this different property. So no matter what consensus protocol you have, you can't have both of these properties, but you can have one. So that's what we've chosen to do with Espresso. So as I said, in optimistic conditions, the design of Espresso basically allows us to have extremely, extremely fast confirmations through the use of a CDN architecture. But it's still robust, right? So even if network conditions are bad, it's still secure. So we call that Web 2 performance with Web 3 security. Espresso currently is already live on mainnet. There are several chains that are already using Espresso for fast confirmations. However, it's a permission mainnet right now. So it's run by around 100 distributed nodes, run by around 10 institutional and community validators. And we are planning to completely upgrade to a decentralized proof of stake later this year. And as I said, Hotshot has been designed to be able to scale to hundreds of nodes. So eventually, we hope this will basically serve as a sort of layer 1.5 confirmation layer on top of Ethereum with the same level of security, using the Ethereum validators for economic security and mirroring that validator set using things like restaking. And that's the ultimate goal. Here are some different ways that Ethereum chains or rollups can potentially use Espresso. It's extremely flexible. We view it as basically a service that any rollup can plug in modularly, right? So if you're a standard, all of these rollups, all of these different types of rollups will still settle on Ethereum, but they can use Espresso for these fast confirmations. They can use any DA they want. They can use any execution environment they want, right? So even if they want to do a non-EVM, like a app-specific VM or like a Solana VM or like a Move VM, that's totally fine too. They can still use their own centralized sequencer. They can also use Espresso for sequencing if they want that. They can even be a based rollup, right, that uses Ethereum's validators for sequencing. What Espresso is really doing is just serving as this layer 1.5 on top of Ethereum that provides extremely fast confirmations. And as I explained, that helps with not just security, but that also helps speed up interop. So that's it. I think there's something wrong with the slides. But if you would like to learn more, just go to our website, and our X account is there as well. Thank you, everyone.